Hello everyone, welcome to our YouTube channel Educated Cherry.
Namaste friends, welcome to our YouTube channel Educated Jerry. In this video, we continue our talk about the origin of the universe. In this video, we know the geocentric models. Roughly 2400 years ago, the Greeks had already devised sophisticated geometric methods and systems of philosophical thought. It should be no surprise, therefore, that they also proposed a more sophisticated cosmology of the flat universe. Theirs was, in fact, spherical, with the Earth ringed by celestial bodies that kept predictable orbits and all encased by a fixed starry sky. An initial version of the geocentric model was presented by Oedicus and was followed by successive modifications. One of its revisions was proposed by Aristotle, who demonstrated that the earth was a sphere. He arrived at this conclusion after observing the shadow cast during a lunar eclipse. He also calculated the size of the earth's shadow at 50% larger than it really is. Aristotle's geocentric model consisted of 49 concentric spheres, which he believed could account for the movements of all the celestial bodies. The most external sphere was that of the fixed stars, which controlled by the behavior of the inner spheres. The starry sphere, in turn, was controlled by a supernatural mover, entity. The, the Greek geocentric model underwent further revisions. Eratosthenes used a experimental method to measure the circumference of the earth, which he overestimated by only 15%. Ptolemy revised Aristotle's model by introducing epicycles, a model in which the planets swivel in smaller circles as they orbit the earth. The heliocentric model, the idea that the sun is at the center of the universe and that the earth revolves around it, known as the heliocentric theory, was first proposed by Aristarchus of Samos, who arrived at the notion based on his estimates of the sizes and distances of the sun and the moon. He concluded that the earth revolves around the sun and that the stars compose a fixed and very distant sphere. His theory attracted little attention, mainly because it contradicted the geocentric theory of Aristotle, then held in the highest prestige there, and because the very idea of the earth moving about was not particularly appealing. About 2000 years later, in 1510, Copernicus set down his own heliocentric model, which circulated anonymously. Copernicus seemed to have foreseen the furor the theory would provoke and only allowed it to be published after his death. The work was brought out openly for the first time in 1453 under the title The Revolution Bus Obrium Coelesti, and carried a dedication to the Pope Paul III. The heliocentric model did not only trigger a revolution within astronomy but also had enormous cultural impact, with philosophical and religious ramifications. The Aristotelian model was so deeply ingrained in the psyche that man from the center of the universe proved an extremely traumatic experience. In the end, Copernicus' heliocentric model won through as the correct cosmology, which raised the question of why uh, Aristarchus' model had not managed to do the same 2000 years earlier. The basic reason is that heliocentric city did not offer any real differential at the time when compared to the geocentric model. The measurements were a little fuzzy, and one theory served just as well as the other in practical terms. Indeed, the geocentric model seemed to fit better with the everyday reality, and it had the added bonus of being a homocentric model, which sat more comfortably with the philosophical and theological schools. After the publication of Copernicus' theory, however, a certain technological and scientific advances rendered it clearly superior to the uh, uh, Ptolemaic system. Tycho Brahe played an important role in advancing instrument-based techniques for making uh, precise measurements with the naked eye, as refracting glasses and telescopes had not yet been invented. These measurements were roughly 10 times more precise than earlier calculations. In 1597, Brahe moved to Prague, where he hired Kepler as his assistant. Later, Kepler was to use Tycho's measurements to establish his law of planetary motion. These laws showed that the planets move in elliptical orbits with the sun at one focus. With this realization, theoretical calculations and measurements acquired much greater congruity than under the older system. If for no other reason, the precision and the economy this afforded would have proved so important on long sea voyages that the laws would have imposed themselves for practical reasons alone. In developing the telescope, Galileo created an instrument of vital importance to astronomical research, as it lends extraordinary powers of magnification to the human eye. When he trained his telescope as the sun, he discovered sunspots. When he focused on Jupiter, he discovered its first four moons. Turning to the Milky Way, he revealed that it was composed of myriad stars. The discovery of galaxy. It was precisely with the development of optical, mechanical, and photographic techniques that the distances of the nearest stars could finally be determined, thus dispelling the notion of a sphere of fixed stars, with the stellar distances now measured and understood to be incredibly long. The interpretation gradually began to take hold that the stars and the sun were objects of the same nature. Each star therefore had the right in principle to host a planetary system. One of the first consistent conceptions of the nature of the galaxy, and surprisingly accurate at that, was made by Kant, who at the age of only 26, and thus long before he was to make his name in philosophy, came into contact with the Newtonian thought and developed the idea that the solar system had originated from the condensing of a gas disk. He also formulated the notion that the solar system belongs to a much larger comprised structure, what we call a galaxy today, and that the many nebula then observed as diffuse stains were in fact similar system which he called island universes. The most important observational advances in terms of a more detailed understanding of the distribution of the stars were made by Wilhelm Herschel, the first to build large telescopes capable to viewing the fainter objects of the heavens with more precision. Stars are both scattered throughout space and grouped into so-called clusters. Studying these clusters, Herschel's found that the stars were not randomly distributed, but that they followed a certain configuration discernible to the naked eye, just like the Milky Way. The Sun, the star closest to the Earth, is some 159 million kilometers away, or rather 8 light minutes, which is the time it takes sun rays to travel from the king star to the surface of the Earth. Mapping the globular star cluster revealed that the galaxy is approximately 90,000 light years in diameter and made of roughly 100 billion stars, all revolving around the same nucleus, some 25 light years from the Sun. It soon became clear that there are innumerable similar formations in the universe. The nebula, generally referred to today as galaxies. When we look at the closest star outside our solar system, Alpha Centaurian was really looking into the past. This star is 4.3 light years away, which means that the light arriving here today was estimated 4.3 years ago. What we see, in fact, is the past. When we look at our neighboring galaxy Andromeda, we were really seeing it as it was 2.4 million years ago. Many of the stars can be observed today ceased to exist eons ago.